Okay, so hello and good afternoon class. So for today's meeting, we would be discussing about the design of steel roof trusses using STAAD.Pro Connect Edition. But confirmation first everyone, do you see my mouse? My mouse cursor?
Yes,
Okay,
sir.
so very good. So once again, for today's meeting, we would be designing steel roof trusses using STAAD.Pro Connect Edition. But disclaimer first guys, for today's lesson, we wouldn't be discussing about the modeling part already since all of you already know how to model our structures in STAAD. Am I correct guys? So alam nyo naman na paano mag-model, right?
Yes, sir.
Okay, very good. So a little bit of a review sa mga hindi nakaalala pero dapat naalala nyo eh. So we actually have three ways once again in modeling our structure. So the first way is by going straight here at this portion right here at your right. Then inputting the coordinates of your nodes. Then after inputting the coordinates of your nodes, you would now be assigning them into their respective beams right here. So this is to be the first method. So the second method is by going to our structure wizard right here at the upper left corner of your screen. So ito yung second approach. And the third approach is by importing. So number 3. So for number 3, we would be importing our DXF file. So DXF file, which you can plot using AutoCAD. So those are three ways which all of you are already familiar with. Okay, so when we are to design our trusses, it is better for us to design just one truss. So kunwari madami tayong trusses, no? It is better for us to just design one and that we will be using the design truss for all of the trusses if they are to be similar in nature. So okay, so after modeling our structure, after modeling our well model, like this one right here, so na pre-made ko ng ating truss, no? The next thing that we will be doing here is that we will be going to the properties tab. So in this properties tab right here, this is where, of course, the property assignment would happen. Okay, so since our steel truss is to be steel in nature, as the word itself says, we would be applying our section here using our section database by STAAD, which is at this portion right here. Teka, sulatan ko para makita nyo, no? So it would be this at the lower right corner of your screen. So can you see it, guys? Confirmation?
Yes, sir. Yes, sir.
Okay, very good. So you would be clicking that. So ngayon, ako palang gagawa niyan. So kiklik ko yung section database and this interface would come out. Tagal. For a while. Okay, so this interface would come out once that you will be clicking the section database. So if you would be clicking at this American code here, this is basically the AISC shapes database. So sulat natin, no? So this is basically the AISC shapes database which you have been using when you are in Principles of Steel Design. It is, it is there. Okay, so if this is to be the AISC shapes database, for example, that in this roof truss right here, I want it to be assigned with a double angle. So I would be going to the angle part. So I don't know if you can read kasi medyo maliliit siya. But assuming that you can, so ito yung angle part natin. So angle. And this interface would come out. So this is to be the available angles for the AISC shapes database. But we have a catch here in the nomenclature part. So as you can notice, no, ito yung pagkakasulat ng mga angles natin. So if you cannot read them here, so I would just be writing them at the left corner of your screen. So ito, ang nakalagay kasi dito at this part right here, this is to be L20202. So what is this? So ito yung naming assignment niya. This L right here indicates that that section is indeed an angle. So L-shaped siya, so that is to be an angle. And these two digits right here, or this first set of digits right here, so I would just be changing the color for you to see it better for a while. So, okay, so as for these two digits right here, this is basically the length of the angle times 10. So this is to be in inches, guys. So this is to be the length of the leg, I should say. And as for this second set of digits, so 20 right here, this is also length times 10 inches. And as for this last set of digits, and in this case isang digit lang siya, this is to be the thickness of your angle times 16. So, medyo nakaharang pala yung pagmumukha ko, no? So, I would just be moving this towards, downward. So, ito angle siya, then ito yung length niya, and the other is also to be its length, and etc. So, for example, that let's say I want our truss to have a section of, let's say, 6 by 6 by 5 over 16. So, I would just be erasing all of this first. So let's say that I want my angle to be, let's say, an angle that is to be 6 inches by 6 inches by, let's say, 5 over 16 inches. So in this nomenclature, guys, for its nomenclature here, this is basically, so L, then multiply this by 10, so 60. Then multiply this again by 10, 60. And multiply this by 16. So 5 over 16 times 16 is basically 5. So I think all of you should agree. So for me to have this section right here, this is basically L60605. So from that, guys, I would be searching for this one right here. So hanapin natin sandali. So L60605. Okay, so it would be this. So once that you found your, once that you find your angle, and let's say that in this setup right here, I want it to be a double angle, and by double angle, literally speaking, dalawang angle siya. So let's say I want my angle to be like this. So ito yung isang angle natin, for example, and this is to be the other angle. So for example, that I want it to be this way for our section for our roof truss, I would be clicking this. So this LD or SD. So LD is this, indicates that its long leg is back to back, and SD indicates that its short leg is back to back. So it really doesn't matter if you would be choosing LD or SD, since our section does have equal legs. So parehas lang siya ng kalalabasan. So I would be clicking that, and I will be clicking add. Okay, so let's say that I will be assigning this to all of the members. So it is either that you would be selecting all of the members, or better yet, if I would just be clicking here and I will be clicking assign to view. Are you guys still following?
Yes, sir.
Okay, very good. So what I did here was just to assign my steel section, which is 6 by 6 by 5 over 16. So that is for the AISC shapes database. But for example, that you don't want to, you want to have a certain section with metric units in it, what you will be doing is that you will be going to the European code. Since Europe uses metric units. So once that you will be going to the European code, go to angle, then basically it is already here. So for our L60 by 60, so, oops, sorry. For a while. Okay, so for our L 6 inches, I should say, by 6 inches by 5 over 16 inches, if we would be converting them into metric, this is basically L 150 by 150 by, so what is to be 5 over 16 in metric? So for a while, as I will be showing you our calculator first. So confirmation, do you see my the calculator on your right?
Yes, po, sir.
Okay, so I will be converting 5 over 16 into metric. So times 5 over 16 times 25 over 25.4, and that is 7.9. So this is basically 8 mm. So by that, guys, our answer here should be 150 by 150 by 8 mm. So this is for its metric counterpart. So what we will be doing here is that we will be searching for 150 by 150 by 8 mm. But I wouldn't bother any longer since I already have my section in here. In here on your right, I should say. So magkaiba lang sila ng pangalan but basically it is the same. So magkaiba lang sila ng unit na ginamit. Okay, but since this is already here, since this is already here, yan na yung gamitin natin guys. So ayan, so let's use that instead. So for us to view what our structure would look like, so let's go to view and let's go to 3D rendering. So basically this is what our structure would look like. So this is to be its top bar. So nakikita nyo guys, puro double angle lahat sila. As well as for the top chord and the bottom chord. Okay, and after modeling, so let's say that you're already satisfied with your section. The next thing that we will be doing here is that we will be applying beta angles if needed. But the question is, in our structure right here, is it needed? So as you can see guys, in this part right here, yung bottom angle natin is to be oriented in this manner. So it is oriented like this. Guys, can you see what I'm drawing?
Nakikita ko, sir.
Okay, very good. So it is to be oriented in this manner. So by engineering judgment, it is better if we would be rotating it. And by rotating it, I mean that it is better if we would be orienting our bottom chords in this manner. So it would be like this. Whereas the unconnected legs are to be at the bottom part. So we would be doing that for two reasons. So first reason, so reason number 1, bending. If this section right here, so if this section right here would bend, it would bend in this manner. And if this is to be your manner of bending, the tension fibers would be at the bottom part. And with that being said, it is logical for us to place this area right here at the bottom part for it to resist more tensile stress. So that is to be reason number 1. And reason number 2, we can actually use this upper connected legs right here as the connection for your web members. So in Tagalog, pwede nating i-welding dito sa part na to yung ating web members. So with that guys, what we will be doing here is that we will be applying our beta angles. So clear ko muna yung screen natin. Okay, so for our beta angles, just click on this part right here at the lower portion of your screen. So it is to be here. Palitan ko lang ulit yung kulay para makita nyo. So it would be here, beta angle. Okay, so click beta angle. Then click create beta angle. Then we would be creating a 180 degree beta angle. So the use for your beta angle is for your section to rotate along its local x-axis. So I would just be pressing OK here. I'm clicking OK. And once that your beta angle is already here, I will be applying it to the bottom chords only. So I will be clicking all of them. So click, hold Control key and click all of the bottom chords. And after that, I will be assigning our beta angle of 180 degrees. Okay, so once that is already applied, I will be going to the 3D rendering view once again, and I will check if our bottom bars are already rotated. So as you can see, and if you cannot, I will be showing it to you na nag-rotate na. So it is, the upper portion of our bottom angles is now to be the connected legs, and the unconnected legs of the bottom truss, bottom chord are already at the bottom part. So renotate lang natin yung bottom chords natin. So are you guys still following?
Yes, sir.
So understood kung bakit natin renotate yung nasa baba. So this is basically optional, pero of course, by engineering judgment, it is better if you would be doing it this way. So okay guys? Are you following?
Yes, sir.
Okay, so very good. Okay, so after our properties tab, so if you are already contented with your beta angle and with your section, the next thing that we will be doing here is that we will be going to the specifications tab already. So we will be skipping this materials tab since when we have applied our section right here, it is already automated to be a steel material. So automatic na siyang nag-steel material. So let's just skip with the materials tab already. So after going to your properties, let's go straight to the specifications tab. So ano bang gagawin natin dito sa specifications tab? So in engineering theory guys that you have learned in your lower years, specifically in mechanics, specifically in statics of rigid bodies, when we are to deal with trusses, we are to assume that each member, so all of these members right here, would only resist axial forces. And by axial forces, what we mean there is tension and compression. So wala siyang bending, just tension or compression. So if you want that to be your approach in our analysis here, what we would be doing is that we would be releasing its capability to hold moment. To have moment in the members. So by that, guys, what we would be doing is that we would be going here at the beams interface. So ito, at the lower portion of your screen. So beam. So click that. Then this interface would come out. So we have two ways actually. The first way is by releasing the moments. So let's say release, then release MY and MZ. So that is to be the first way. And the second way is by going here straight to truss. So ito meron tayong truss dito. So once that you will be clicking this, the moments would now be released. So if you would be doing that, it would remove the capability of your members to withstand bending moments. And if you also want it to withstand, if you want to release the capability of your member to intorsion, so click nyo lang lahat ng actually MX yun eh. So MX, MY, and MZ. So that is to be how you would be assigning it to be a truss member. However, if you are building a roof truss, so let's go back to our 3D rendering view right here. So ito nga yung truss natin, no? So however, if you are to build a roof truss, you wouldn't be cutting your members. So let's say that these are to be your members. So these are to be your members. You wouldn't be cutting them and connecting them on how you analyze them theoretically. So if you are to build them, these top chords right here would be one homogeneous member. So iisa lang yan guys, walang putol yan. As well as for the other part, other top chord, as well as for your bottom chord. So once again, that if you are to build them, these members right here would be homogeneous in nature. Homogeneous in nature. Okay, so if that is to be the case, by the way, also if you would be subjecting this to load, so for example that you would be stepping here, so let's say that you are here, you are stepping at this part of the truss. The tendency of this member right here is to bend in this manner. So with that being said guys, hindi na siya truss kasi meron na siyang bending. Because if you would be analyzing it as a truss, once again, you are only subjecting it with compressive stresses and not bending moments. Okay, so with reality taken into consideration, it is logical for us not to release any moments for your top chords and for your bottom chords. In other words, we are to treat your top chord as a beam, as well as your bottom chord. So you will be treating your top chords and your bottom chords as beams. So that is reality taken into consideration. Okay, so is it clear guys? Nakasunod ba?
Yes po, sir.
Okay, so very good. So that is just for the top chord and the bottom chord, since once again, you wouldn't be cutting them per member. So your top chords is to be one homogeneous member as well as for the bottom chord. So i-treat na lang natin siya na beam. But what about for the web members? So as you can see that this is to be of course your web members. So when you are to connect these ones right here, even though that you will be cutting them as per its lengths. So kung ito yung length niya, ito yung puputulin mo. But if we are to weld, or let's say if we are to weld or if we are to connect it via bolts in these parts right here. So for example, etong member na to, i-welding mo yan. Of course, you would be welding them at this portion. So you will be welding them at this portion and you will be welding it by this portion. In this portion. And when we are to weld our members in our trusses, what we are actually doing there is that we are actually fixing it by a certain degree. So fix. So we are actually fixing it by a certain degree. And by fixing, so fixed support, ring any bell. So adun, dinalagyan natin siya ng onting moment restraint. So with that being taken into consideration, guys, we are actually allowing our members right here to be subjected with a very small amount of a moment restraint, or let's say a bending moment, I should say. Kasi nga finifix mo siya dyan, no? So, ayun. So in our design, guys, if I am to be the engineer, or let's say that you will be the structural engineers very soon and you would be listening to my advice, I say that it is logical for us to have at least 1%. So let's say we would be giving our web members 1% of the capability to hold moments because of the presence of welding. So 1% moment restraint. So in Tagalog, guys, bibigyan natin ng English na lang para mahirap. In English, we would be giving our web members the capability of holding, of allowing or resisting moments if we are to fix them via welding. So for us to do that, guys, what we would be doing is that we would be going to beam once again right here. Then we will be partially releasing it. And by partially releasing it, in Tagalog, hindi mo i-release lahat, onti lang. So from that, guys, I would be clicking here, partial moment release. Then I would be clicking MP. Then I would be releasing 99% of the moment. So I would just be leaving 1%. So 0.99. So I would be clicking add. So that is for the start of the beam. So add. Then I would be defining another one, which is to be in the end location. So end, partial moment release, MP, then 0.99. So once again, what I am actually doing here is that I am releasing 99% of the capability of the member to resist moments. So ano ba natitira pag nag-release mo yung 99? Of course, matitira dyan 1%. So there, and from that, guys, I would now be assigning this moment restraints, release moments into our web members. So are you guys still following?
Following po, sir.
Okay, very good. How about for the others? Aside from Mr. Parel, nakasunod pa, guys?
Yes, po, sir.
Okay, so here, so I have already assigned my my partial moment releases to each of the web members. So take note, just the web members. Okay, so the next thing that we will be doing here is that we will be assigning our supports here. So go to supports tab. So supports, then we will be defining it here. So let's say that I want my my structure to be a simply supported truss. And by simply supported, that is to be pinned and roller. So go to pin right here, pin, then click add. So I will be assigning it here. So this is to be a pin connection at this part already. So this is to be a pin connection. And as for the others, I want it to be a roller connection. But we have a catch here once again. If this is to be, if this support right here is to be a roller connection, its restraint would be just Fy, or the force along the global Y direction. So you wouldn't have, the support wouldn't be capable of resisting moments, resisting Fx, and resisting Fz. But the thing is, if we would be releasing Fz right here, the tendency of your truss is to go to that direction. If you understand. So let's say that I would be going to the top view. So I would be going, ganito na lang pala. So if this is to be our supports, of course we want it to be fixed, to have the capability of resisting your Fy. And we do not want this support right here to to resist Fx. But for Fz, so in a nutshell, yung Fz kailangan nating ilagay yan kasi pag di natin linagay yan, magro-rotate yung buong truss natin. So in our support right here, this is basically let's say a customized roller support. So yung roller niya pero nakapag-resist siya ng Fz. So from that, guys, what I would be doing here is that I would be going to create. Then I will be going to enforced but. So enforced but. So this is to be the releases. So I would be releasing the moment restraints here. And I would also release Fx since I am allowing my truss to move along the x direction in that support. So Fx. So click add. Okay, so once that this support is already here, I would now be assigning this to this node. So assign, then click here. So as you can see, this is to be its restraint. Okay, so, oh, by the way, i-edit pala natin tong support number 3. So this MX right here is to be your torsional. So if this is to be your X, so if this is to be your X-axis, this is to be MX. Of course, we also do not want our structure to rotate in that direction. And it is better if we wouldn't be releasing this to avoid instability. Kasi pag linagay natin yan, sasabihin ni STAAD mamaya unstable daw yung ating structure. So let's do that instead. Or better yet, let's not do that for you to check what for you to see what I am referring to para makita nyo yung warning. So cancel. Okay, so the next thing that we will be doing here is that we will be going to the loading conditions. And ayun, no, so I have already pre-solved the loading conditions or the load cases, which you will see right now. So confirmation, everyone. Do you see an Excel file to your left?
Yes, sir.
Okay, so as you can see, guys, meron tayong dead load. So we have our dead loads here. We also have our live load. Oops, this should be 0.6, I should say. So this is to be our roof live load, and this is to be for our wind load. So for our dead loads, guys, for our dead loads and for our roof live loads, we would be referring to NSCP 2015. And for our wind loads, well, we will be also referring ito NSCP 2015. Naihiwalay ko lang, hindi ko sinasadya. So we would be referring to NSCP 2015 for all of our loads. So as you can see, if you would be opening your NSCPs, the magnitudes there would be in terms of pressure. So in terms of kilonewtons per square meter. And since if they are to be pressure, we should convert them first into line loads if we would be applying them here. So for us to convert them into line loads, what we would be doing is that we would be multiplying the pressure to its tributary width. So ano ba yung tributary width? So suppose that this is to be the top view of our truss. And let's say that we have another truss right here. And let's say that we also have another truss right here. So the tributary area of a certain truss is basically the area that that truss will carry. And in this case, if this is to be your truss in the middle, and let's say that this is to be spacing W, just for example, or let's say spacing S. So let's say that this is to be spacing S. The tendency, this truss right here in the middle would carry half of it. Half of the space here. Half of the area here. And also half of the area here. So meaning, if this is to be your tributary area, this is to be S over 2, and this is also S over 2, as well as for the other side. So S over 2 and S over 2. So S over 2 plus S over 2, this is basically S. So our tributary width here is to be S. So suppose that we would be having a certain pressure right here. For us to convert it into line load, we would be multiplying it by S. So let's do that for our wind loads and our live loads. Our dead loads and our live loads, yes. So I would be clicking here at the load case details. Then, oops, anong nangyayari? Medyo lumaki yung ating Excel file. So anyway, so there, and I would be clicking here, add load cases. So I would be clicking add. So I would be defining my dead load. So let's say my dead load is to be DL, and my live load is to be LL. Let's say that we would be having two wind load cases. So wind, let's say WL1 and WL2. Okay, so here we go. So the next thing that I will be doing is that I will be assigning the wind load already. I mean the dead load already, I should say. So for the dead load, so as you can see at the Excel file, but confirmation, is it readable? Nababasa ba yung mga nandito sa Excel file natin, guys?
Yes po, sir.
Okay, so very good. So for our dead load, for the roofing sheets, insulation sheets, and purlins, so those are to be 0.05, 0.05, and 1 kilopascal respectively. So I will just be writing them in our screen. So 0.05 plus 0.05 plus 1 kilopascal. So the total here is to be 1.1 kilopascal. Oops, hindi pala 1 kilopascal to. This should be 0.1, I should say. So 0.1 kilopascal. So with that, our dead load, so DL for top chords is to be equal to 0.2 kilopascal. So this is just for the top chord. And once again, we should convert this into its respective line load. And once again, for us to convert it into line load, what we would be doing is that we will be multiplying this by the tributary width. And the tributary width is already given in this Excel file. So nandito siya, itong truss spacing. So it is to be 3.5 meters. So meaning, well, basically the truss has spacing of 3.5 meters. So from that, guys, I will be multiplying this 0.2 kilopascal right here by 3 meters. And the answer here is to be 0.6 kilonewtons per meter. So are there any questions, guys? Okay, so understood?
Yes, sir.
Okay, very good. So that is for the top chord. But what about for the bottom chord? So in our loadings here, we have our ceiling right here. Our ceiling and our mechanical, di ko lang ba't ko linagay na MEP dito pero wala namang plumbing sa bubong. So this is for the ceiling and it's for accessories. So it is 0.35 kilonewtons per square meter. So I would be writing them here once again. So dead load for bottom chord. So this is to be equal to 0.35 kilonewtons per square meter. And we will be multiplying this by tributary area. Oops, may mali pala tayo dito sa una. Ang tributary area pala natin is, tributary width natin is 3.5. Hindi ko nakita, no? So 3.5 pala dapat to. So 3.5 meters. So basically, this is to be 0.7 kilonewtons per meter. Okay, and as for this one, 0.35, we would be multiplying it by our tributary width of 3.5. So 3.5 meters. And this is to be equal to, so let's make use of our calculator at hindi ko na kayang i-mental yan. So calculator. So I need your help, calculator. So 0.35 times 3.5, I should say, and this is to be equal to 1.225. So 1.225 kilonewtons per meter. So that is to be it. So let's just assign our dead loads right now. So for us to assign it, just go to dead load. But before that, let's hide our calculator first. So let's go to dead load, click add, and then let's go to self-weight. Of course, kailangan yung self-weight na yan. So I don't think kailangan nyo pa ng explanation but kailangan yung self-weight. So I would be clicking add here. And for the member load, So for the member load right here, guys, our force at this portion, so 3.5. This is, 0.7, so negative 0.7 since this is to be a gravity load. So meaning it is going downwards. So negative 0.7, I will be adding that. And as for this one, itong nasa baba, ito yung pang ano natin, pang ceiling natin. This is to be negative 1.225. So click add. Okay, so ayan 1.225 and 0.7, they are already here. So the next thing that I will be doing is that I will be assigning them. So clear ko muna yung buong screen. Then itong self weight, assign to view na lang yan since all of these members right here have their own respective weights. Then click yes. Then as for the first one or 0.7, this is for your top chords. So I would be assigning them here. So this is for your top chords. And for your bottom chords, I would be assigning them here. I would be assigning negative 1.225 to the bottom chords. So assign to selected beams. So are you guys still with me? Are you guys still following? Okay, very good. So what about for the others?
Yes po, sir.
Okay, sige. So ayan. So that is for dead load. So for our live load, so it would be the same. So what we would be doing here is that we will just be multiplying our live load, our pressure right here, which is 0.6 kilopascal by the tributary width. And once again, the tributary width is to be 3.5. So 0.6 times 3.5. So I will just be writing them here. So for our live loads, and this is just for the top chord, guys. So we don't have a live load for the bottom chord. So this is basically what was that again? So 0.6 kilonewtons per square meter multiplied by the tributary width, and our tributary width is to be 3.5 meters. So once again, I need the help of my calculator right now. So calculator. So that is to be 0.6 times 3.5. So it is to be 2.1 kilonewtons per meter. So 2.1 kilonewtons per meter. Okay, so I would be hiding my calculator as I will be assigning our wind load already. So click LL, click add, then go to member load, uniform force. Then this is to be negative 2.1 kilonewtons per meter. And it is acting along the global y direction since our live load is to be a gravity load. So click add. Then we will be assigning this to the top chord. Okay, so click assign. Oops, assign to selected beams. Then there. So far guys, are there any questions? Or do you understand our lesson? Yun na lang pala yung tanong. Do you understand, guys?
Yes po.
Okay, very good. How about for the others? Sino bang pwedeng matanong? Miss Nicole, okay? Do you follow? Naku, wala. April, do you follow?
Yes po, sir.
Okay, very good. How about for the others? Mr. Sipat, do you follow?
Sir, yes, sir.
Yeah, very good. Okay, so ayan, yan yung sa wind load and sa live load natin. And for our next, so for our wind loads, so we would be having a certain catch here. So for our wind loads, so labas ko lang sandali yung ating Word file. So I would be, oh, by the way, for our wind loads, these are to be the parameters. So we have our mean roof height, roof type, wind speed, our exposure category, our importance factor, our KZT, our lambda, and our KD. So what we will be doing here is very similar to what we have been doing for the past couple of weeks in the main wind force resisting system, but this time we would be dealing with components and claddings, which we call C and C. So for our C and C, we would be making use of this. So, wait. So, word. Tayo lang natin lumabas yung aking manual. So, confirmation guys. Do you see? De, ganito na lang pala. Hello po ma'am. So, ingat po ma'am. Thank you ma'am. Okay, so, continue tayo guys. So, bye pala muna kayo kay Ma'am Yuri.
Ito.
Bye, ma'am.
Good po, ma'am. Bye po.
Thank you, ma'am.
Bye, ma'am. Thank you, ma'am.
Bye ma'am. Thank you also. God bless too ma'am. Take care ma'am. Okay, so guys, anyway, so ito pala no, yung sa ating Word file, alisin ko na siya dun sa ating screen. I mean sa left, palaki na lang natin siya so full screen tayo ngayon. So ito kasi yung ating manual. So wait. So for our wind loads guys, it would be like this. So we have a couple of zones. So meron tayong zone 3, zone 2, zone 1. Well, yun lang yun. Zones 1, 2, and 3 only. Pero tayo ma-undo. Ayun, pwede pala. And for this one guys, if you want to see this is basically on page 143 in the National Structural Code of the Philippines. And ayun ang gagawin lang natin dito guys, in this part right here. This is basically, so for our pressure, it is very similar to what we have been doing before. So our pressure is to be equal to lambda times kZt times P net. So same formula, but this time for our P net, we would be referring to another table. Kasi yung table na anong tawag dito, na rin-refer nyo dati is to be for the main wind force resisting system. And for this one guys, this is for our wall and roof pressures. So for our roof pressures, by the way guys, dito pala natin kinuha yung live load natin, no? So for our live load, it was basically this. Ito yung live load natin kanina. So this is table 205-3. So this is for our roof live loads. Okay, so balik tayo sa wind load kasi alam naman na natin yung live load na yan, no? So, okay. So this is for our, ano na pinag-uusapan natin dito? So this is the equation that we will be using once again. So for your lambda, this is already given. So yung lambda natin na to, given na yan. This is to be the adjustment factor. Then yung kZt, given na naman yan. This is to be 1.0. And your P net is to be given by this table right here. So in this table, it is to be dependent upon the basic wind speed, the zone. Itong zone na to guys, hindi to yung hindi to yung zone 2 pati zone 4 sa seismic ha. These zones right here, as you can see, 1, 2, and 3, these are to be these zones. So ito meron tayong mga zones dito. Zone 1, Zone 2, and Zone 3. So those are to be these zones right here. And it is also dependent upon the effective wind area. So ano ba yung effective wind area natin? Ito ba yung tributary area natin? Partly yes, partly no. Because if we would be going here, so according to NSCP 2015, effective wind area does not necessarily correspond to the area of the building surface contributing to the force being considered. In Tagalog, hindi daw siya automatically considered as the tributary area. And according to ASCE 7-10, our effective wind area A for component and cladding elements, which is, once again, our roof, yung roof natin, component and cladding din siya, the effective wind area is the span length multiplied by an effective width that need not to be less than 1/3 of the span length. So suppose that we would be having this. So let's say that this is to be our truss. So top view to guys, no? Confirmation, may nakita ba kayong drawing kong line?
Opo, sir.
Okay, very good. Maganda ba? De joke lang. Ito yung kunwaring truss natin on top view. And of course, we would be having another truss right here. Another truss right here. So ito, yung spacing ng nasa nasa example natin, this is to be 3.5 meters, as well as for this other one. So 3.5 meters. So this is not drawn into scale guys, tansya ko lang yan. Pero kunwari pantay yan. So it is said here, for its effective wind area, The effective wind area is the span length. So, ang span length natin is to be 20 meters. So, ito, wait lang, 20 meters ba? Check ko nga muna, mamaya mali ako eh. 20 meters yung span ng truss natin. So, this is to be 20 meters. So, it is said here that it is basically 20 meters times effective width. So, kung ito yung, ibayin natin yung kulay sandali. So, if this is to be our tributary area for the one in the middle, so this is to be its tributary width. So, tributary width niya is to be 3.5 meters. So, ang sabi dito, it is 20 times 3.5. So, that is basically this one right here. But, it is said here that the effective width should not be less than 1/3 of the span length. So, 1/3 of the span length, teka, calculator ko na lang, mapahiya pa ako ng di oras eh. So, teka lang, palabasin ulit natin yung calculator natin. So, calculator, then calculator. So, 20 divided by 3. So, this is to be 6.6 as you can see at the right portion of your screen. So, 6.6 siya. So, meaning that ito, since this is to be lower than 6.6, instead of 3.5, we would be using 6.6. But take note guys that this is only for the wind load. Hindi kasama yung dead load pati live load dito. And ito lang siya sa effective wind area lang siya. So ayun, ang gagamitin natin dito is to be 6.6. So for our effective wind area A, this is to be 6.6 times 20 meters. So with that, our effective area, once again, getting the help of our calculator right here, this is to be 6.6 times 20. This is to be 132. So 132 square meters. So ito yung effective area na pagbabasihan natin para check natin yung wind load. So if we would be going back here, guys, nakikita ba siya? I mean, nakikita ba yung mga values? Hindi.
Kita.
Nakakita po.
Okay, so very good. Okay, so if that is to be it, so according to this column right here, this is to be its effective wind area, and ang nasolve natin is to be 132, as you can see at the in the calculator to your right. And ito, dito, ang pinakamalaki niya is 9.5. So masyado nang malayo, no? Pero okay lang yun. Ito pa rin yung gagamitin natin. So 9.5. So meaning, for our zone 1, we would be having a pressure of, teka, ano na yung basic wind speed natin? So, palabasin ko lang Excel file natin. So, ang sabi dito that our basic wind speed is to be 200 kilometers per hour. So, basically guys, if you would see here, teka, lisin ulit natin yan. So, 200 kilometers per hour, meaning that we will be using this column right here. So, intersection nila, so dito. So, gagamitin natin to for zone 1, this one for zone 2, and this one for zone 3. But if we would be going back up here, so ang dinidesign kasi natin na truss guys is to be this, the one in the middle. So, ito yung dinidesign nating truss. So, it would be this one right here. So, as you can see, if this is to be our roof truss, we do not have pressure for zone 3. Ang meron lang tayo zone 2, zone 1, and zone 2. So kung ayaw nyo maniwala, check nyo sa NSCP nyo, yan yun. Yung zone 3 kasi natin is to be in these parts only. Ito mga corner. Hindi naman natin dinidesign yung corner sa ngayon. Ang dinidesign natin is yung nasa gitna, which is to be much more conservative. So Control Z ko lang muna. So from that guys, ang kailangan lang natin is to be for zone 1 and zone 2. So I have already listed these parameters guys. So, and then ito pala guys, no? Itong 0.55 right here. So this one at the left portion. So dito sa mga to, ito mga direct pressure or positive pressure. And this one right here is to be your suction pressure or negative pressure. So puro negative sila, no? Kumbaga hinihigop niya yung, wait lang, tama ba yung term? O, parang tama naman ata. Hinihigop niya yung bubong nyo palayo sa bahay mo. So it is to be an uplift pressure. So for a while. Okay, so anyway, so I have already listed all of this. And by the way guys, meron din pala tayong overhang. since ito yung overhang natin, kukunin mo din yung effective wind area. And ayun, because if we would be going back to our model, since our column is to be here, so our column is to be at this part right here, ito guys, overhang to. Kumbaga cantilever yan. So do you guys understand? So cantilever to, no? So overhang to. Do you guys follow?
Understood po, sir.
Okay, very good. How about for other students not named Mr. Parel? Okay lang kayo guys? Naintindihan nyo? Kasi naintindihan
Yes po,
ni
sir.
Mr. Parel, ayun, ni Mr.
Yes po,
Basco,
sir.
ni Mr. Filio, Mr. Gondran, and okay, so very good. So ito, if this is to be an overhang, meron din tayong pressure dyan. So, meron din tayong pressure pataas dito. Oops, sorry. So, meron tayo ditong pataas na pressure dyan. Kasi nasa labas yan, kumbaga, kung isipin nyo kung nasa labas yung bubong nyo, of course, it is subject to wind load. Pero kung nasa loob yung bubong nyo, parang etong bottom chords natin dito, walang wind load dyan. Okay, so, anong gagawin natin next? So, it is already indicated actually. So, na-presolve ko na siya. So, ang gagawin nyo lang ulit is to be lambda kZt times P. P yung pinagkukuha natin kanina. Teka, palakin na nga lang natin ito. So, ito. Sorry. So, ito siya guys, no? Ito yung direct pressure natin which is 0.55. Then, ito yung upward pressure natin. So, negative 1.1, negative 1.76. Actually, di pala natin kailangan itong zone 3. Delete na natin yan para hindi na nakakalito. Okay. And for this portion right here, for your zone 1, ito pala guys, ito pa lang yung pressure. And kung ulitin ko lang, ang formula natin for our pressure is to be, teka, pangit ng color, ibahin natin para yung kita sa gray. So, RP right here is to be equal to lambda times kZt times P net. Whereas your lambda is already given, this is to be 1.09. So, nandito na din siya sa Excel. Our kZt is to be equal to 1.00 or also given, and our P net would be this ones right here. So, ito, and ito. Okay, so lagay na lang natin siya dito para direkta. So, for this, since this is just your P net, multiply ko na siya ng 1.09. Oops, sorry. So, ito na yung bagong direct pressure natin. And as for this other one, we would also be multiplying it by 1.09. Oops, sorry. And, so, ganun din dito sa kabila, no? So, times 1.09. So, ito na yung mga pressures nila. Pero hindi pa tayo tapos, guys, since this is to be just a pressure. Ang gagawin nga natin dito is for us to convert it into a line load for us to apply it in our trusses. So, with that, guys, i-multiply ko na din to ng tributary width natin. So, times 3.5. Oops, sorry. Times 3.5. So, ganun na din dito. Times 3.5. Times 3.5. And times 3.5. So, as well as for this one right here. So, multiply na din natin siya sa 1.09. Then, ito din times 3.5. So, actually, itong mga ito na guys, yung ating line load. So, from that guys, ito yung mga i-multiply na natin, ano? Okay, so, teka. Palabasin ko lang yung Excel file ulit natin dyan sa right side para makita nyo. Ayan. So, confirmation guys, malilinaw ba yung mga values sa left side ng screen nyo?
Yes, sir. Clear po.
Okay, very good. Okay, so from that guys, so for our direct pressure, dun natin siya i-assign sa WL1. So for our direct pressure, so parehas lang siya, may it be zone 1 or zone 2. Teka, ipalabasin ulit natin pala yung isa nating document. Pero ba't wala? Wala isang document natin. Ito pala. For a while. Para mas maayos yung ating nasa screen. Pakita ko lang yung ating ayun. So ito. Then I will be moving this. Let's say to the lower portion. So, oops, mali. So ito pala. Hindi yan. Teka lang. Ito pala guys. Ito. Lipat natin dito para makita nyo lang yung mga zoning. So for the direct pressure guys, so same for zone 1 and zone 2, 2.09 pareho. Okay, round up na natin to 2.1. So from that guys, I will be going here to our wind load, click add, then member load, then negative 2.1. Renound up ko na siya guys. But this time, it would be acting towards the local direction or local y direction. And well, negative 2.1. So ayan, and if I would be clicking add, and if I would be assigning them to the top chords, it would now look like this. So ayan, so do you guys see? Do you guys follow? Yun na yung wind load natin na yung direct pressure. Guys, okay?
Yes, sir.
Okay, how about for the others?
Yes, sir.
Okay, very
Yes,
good.
sir.
Okay, eto rin ni-request ng mga kaibigan niyang tawagin daw siya eh. Oh, Miss Andres, do you follow?
Sir.
Do you follow? Kayla?
Yes po.
Okay,
Yes,
very
sir.
good. How about for the other Kayla? Miss Pinto? Do you follow?
Yes, sir.
Okay, very good. Okay, sige, let's proceed. So ano na yung gagawin natin next? So next, let us assign the negative pressures. But this time, as you can see, yung zone 1 natin is iba sa zone 2. And if we are to make this one bigger, so yung zone 1 natin guys is yung nasa gitna. And yung zone 2 natin is yung nasa gilid na nasa taas pati nasa baba. And the dimension of our zone 2 or the width of our zone 2 is to be the value for your alpha. So the value for your alpha, you already know how to solve for that. And to save us some time, I have already solved for it. Well, already. So balik tayo, no? So dito. Teka, nasa ba Excel file natin? Ano ba yung alpha natin? So, ang sabi dito, yung alpha daw natin 2 meters. Teka, lista ko lang dito para hindi ko makalimutan. So, alpha, ang pangit ng color. So, our alpha is to be 2 meters. Okay, so, balik tayo sa pressures. So, for our upward pressure, I would be assigning, so, member load. Teka, this is to be negative 4.1965. So this is basically for your what do you call that? This is for your uplift in zone 1. So I would be clicking add. Hindi, mamaya pa pala. Di, mas magandang zone 2 pala muna tayo. Ba't ko pa in-exit? So let's go to zone 2 first. So zone 2, that is to be negative 6.7144. And we will be assigning it at this location right here. And by the way, and this dimension right here is to be alpha. So 2 meters to. So ito kumbaga yung, I'm sorry, teka. Kumbaga ito yung paglalagyan natin ng member load. So lalagay din natin siya dito mamaya. Then dito. So lagay natin yan since yun yung mga zone 2 natin. Are you guys still following? Na-envision nyo ba yung magandang drawing ko? So ito yung sa zone 2 natin guys. Do you guys follow?
Yes po.
Okay, very good. So with that guys, so ito pala ang magnitude daw natin dyan is to be 6.714. So which is to be this one right here. So 6.714. So for its D1, oops, no wala. So for its D1, it is to be 0 kung ito muna yung unahin natin guys. So ito muna yung unahin natin. So D1, 0 and D2 is to be 2 meters. So I would be clicking add here. So assign ko siya dito. So, assign to selected beams. So, oops, teka, by the way, hindi dapat siya sa global Y direction. It should be on the local Y direction. So, Y local, then modify. And this should be positive, I should say, since it is to be acting upwards. So, positive 6.7144, click modify. So, basically, this is to be it. And as for the others, so ganun din. As for this one right here, oops, sorry, mag-add na naman tayo ng ating bagong wind load. So, member load. Then, positive 6.714. But this time, mag-iiba yung ating D1. Yung D1 natin is supposed to be, teka, asan ba yung, kung ang length niya is to be 3.2, which is to be this one. So, ang length niya is to be 3.2. 8295. And, teka. So, ang length, teka, erase na nga lang natin lahat. So, if this is to be 3.2, so 3.28295. And this should be 2 meters. So, 2 meters dapat to. So, meaning that if this is to be 2 meters, this dimension right here should be 3.28295 minus 2. So, from that is to be 1.28295. Din ako mag-calculator dun. So, 1.28295. So, that is to be for D1. And for your D2, hanggang end na siya. So, that is to be 3.28295. So, click natin ngayon yung Y local, then click add. So, that is for this member. Assign lang natin sandali. So, don't worry guys, medyo malapit na tayo, no? So, ayan. And what about for this? Teka, magka-length ba sila? 2925. So, ito pala, basically, ito din yung i-assign mo. So, same sila. And as for this, i-assign mo naman yung ginawa natin pangalawa. So, this is for our zone 2. And for our zone 1, we will be assigning them here. Tingnan mo yung zone 1 natin. So, click add once again. So, member load. Looking at the Excel file to your left, ang zone 1 natin is to be negative 4.1965. So, 4.1965 since pataas siya. So, Y local. Then, click add. So, assign natin siya dito sa dalawang to. So, paano na to? Ayan. Then, meron pa tayong natitira dito sa portions na to. So, pwede ata natin copyhin yung dito sa kabila eh. Tama. Pero mamaya na. Sige, manual natin, no? So, click add. Then, member load na naman. Then, 4.1965. So, kanya-kanyang technique. Maaari yung technique ko ngayon, hindi yun yung gusto nyo. Basta ang importante, mailagay nyo yung loads nyo sa roof structures nyo. So, 4.1965. So, for your D1, lagay natin dito yung, yung 1.28295. Ata yun. Hindi pala. 2 meters. So, 2 meters up until 3.28295. Then, dito naman sa isa, this is to be, teka, assign nga muna natin kung tama yung pinaggagawa ko. So, assign to selected beams. So, basically, yun siya. And what about for this? So, 1 point, okay, sige. So, for these two right here, ang gagawin natin is, mag-add na naman tayo, same old. So, basically, ito na pala yung pinakamahirap dito sa sa pag-design ng roof truss, no? Yung wind load. So, after this, easy peasy lemon squeezy na, no? So, member load, uniform force, and ito, 4.1965 pa rin, Y local pa rin. And ito, yung coordinate na ilalagay natin dito is from this portion up until this portion. Ito kasi yung zone 2 natin at yung zone 2. So, isasagad lang natin yung load natin dito. So if that is to be zone 2, itong coordinate na to na nilagay natin kanina is 1.28 something. So with that being said, said guys, that is to be 0 up until 1.28295. So click add. So assign natin siya ngayon dito sa dalawang to. So basically yan na yung ating upward pressure. Pero meron pa pala tayong overhang guys. Itong 11.5213 which is dito sa dalawang sides na to. Idilagay natin yun. So click add. So member loads. Ito kahit sa global y direction since this is to be vertically upwards. So 11.5213. Okay. So add. So assign natin siya ngayon. Okay, so here we go. So this is to be our pressure. So do you guys follow? Okay, malapit na natin itong tapusin lahat-lahat. Do you guys still follow?
Yes, sir.
Yes po.
Okay, very good.
Po, sir.
Okay, so the next thing that we will be doing is that we will be defining our load combinations. And since I have already made my automatic load combination for NSCP, yun na lang lagay natin. So let's say that this is to be load combination 101. Ito alam nyo na itong mga to. So kahit di ko na-explain. So service and LRFT. So click add. Ngayon check natin no if we would be having errors. And disclaimer, magkakaroon tayo ng warning. So analysis command. Then perform analysis, no print, click add. Then run natin analysis. So, ayun na yung sinasabi ko guys, wala tayong error but we have one warning. So, according to the warning, it is said in the warning that we would be having a certain instability. Kung natatandaan mo yung lesson natin kanina, dun sa instability, pero wait lang, may nakaharang dun sa ating screen. Ayan pala. So, ayan. So, as you can remember earlier that when we are to be defining our support right here, kapag wala tayong restraint sa MX, which is yung moment along this direction, we would be having instability. Pero for example na yung mga force nyo walang kinalaman dun sa sa instability dito, okay lang. So basically if you would be pushing through with our model right here, tama pa rin yung makukuha nating answer. Pero for example na medyo ok tayo ngayon, medyo OC tayo ngayon, ayaw natin ng warning, it is better that we would be releasing this, we wouldn't be releasing our MX para itong support na to mag-resist siya ng MX or ng moment na to. So if I would be changing it, so ayun kasi no guys, kahit na plain truss lang yung ginagawa natin, STAAD would always assume that we are modeling a 3D model. So, ganun. So, sa totoo lang, yung mga loads na pinaglalagay natin dito, wala namang kinalaman dun sa MX. Pero, ayaw ko nga kasi ng warning dun sa ating result. So, mas magandang ilagay na lang natin para mawala yung warning. So, once again, run analysis, click save. Then as you can see, we do not have an error and we also do not have a warning. So the next thing that we will be doing right here is that we will be checking for its adequacy. So dito kasi sa STAAD when you are to design a steel section, it is more of a trial and adjustment method. So I don't want using the trial and error method kasi pag trial and error may error doon. It is better for you to use trial and adjustment. So mas magandang wording 'yun. So with that guys, we would be clicking load list right here and we will be selecting the load combinations for LRFD. Kasi gusto kong mag-design using LRFD. But if you want ASD, di bahala kayo. Pero ngayon gusto ko LRFD. So I forgot to define envelopes, So wag na tayo mag-envelope, kahit i-select na lang natin tong mga load combinations natin for LRFD, which is the one in the 100 series. So click next right here, then click OK. Then ayun, meron na tayong, may load list na ba tayo? Naisama ba? Parang ayun. So we already have a load list right here. Then the next thing that we will be doing is once that we already have our load list, is to design our steel members. So click nyo to sa taas. So this one right here, steel. So click that, steel. Then go to code AISC 360-10. So this is for the code in NSCP. So AISC 360-10, then define parameters right here. So define parameters. Then ito, medyo similar siya sa reinforced concrete, no? Pero ang kailangan lang natin dito, guys, is ito method. Guys, this one right here. So method, if you want to design it in ASD, click this. And since I want to design it in LRFD, I would be clicking this. So click LRFD, then click add. Then FYLD, so this is to be the yield strength of the steel. And according to our Excel file, our FY is to be 248 megapascal. So 248 248,000 megapascal, then click add. And if you want to indicate the ultimate stress, FU, you can put them here. But since I want this one, I want our steel section right here to be welded. Its connection to be welded connection, we wouldn't be needing the ultimate stress kasi wala naman tayong tensile rupture stress if we would be making use of welds. Kapag, magkakaroon lang tayo ng TRS if gumamit tayo ng bolts. So if you do not believe me and student ko kayo ng steel design, bawiin ko yung grade nyo. Pero biro lang yun. So ayun guys, no, if this is to be a welded connection, its failure is to be in terms of yielding. So walang tensile rupture stress dyan. But for example that you would be designing this in a bolted connection, you should include the FU or the ultimate stress. So ayun lang naman siya, no? So from that guys, I would be assigning our FYLD to all of these members. So assign to view, click assign, click yes. So ayan na siya. So another thing, click on commands, then check code. So by check code, yun, i-check nyo yung code kung pasado yung mga members. So I would be clicking add. So in this check code right here, this is, stability is already included in that code. So if you can remember in our steel design before, if you were my student, na i-check nyo pa yung KL over R, if it is to be in terms of, kunwari, kahit tension stress siya, kahit tension member siya, no, I should say, kailangan nyo pa rin i-check yung stability niya, yung KL over R if it is less than 300. So nandito na dun yun sa check code. So ayan na muna tayo. So click close, then run analysis na ulit natin for it to design it already. So yun, tapos na. So view output file. Actually guys, hindi designing yung ginawa. Ang nangyari dito is basically an adequacy checking. Di ba nag-assign tayo kanina ng 6x6? So check niya ngayon kung adequate. So from that guys, just scroll down here. Pero hindi siya nag ano tawag dito? Hindi siya check code. Bakit di siya nag-check code? Ay, hindi ko pala na-assign guys. So click on check code, then assign to view. Okay, then let us repeat the process. Okay, so here we go. Okay, so ito na yung output file natin na bago. So if you would be scrolling down, ito na yung mga members natin, no? So puro pass siya. Parang kayo disem, puro pasado, no? So puro pass. Check natin kung may fail. So basically guys, wala nag-fail. So dapat kayo din. So wala nag-fail sa sections natin, wala din dapat mag-fail dito sa section natin sa mga class codes nyo. Anyway, and if you want to check its utilization ratio, the next thing that you will be doing is that you will be going to post-processing right here. Then, tawag dito. Sige, select na natin lahat. Click apply. Then, okay. Then, after which, go to utilization ratio right here at the upper portion of your screen. So, utilization ratio. Then, basically, guys, ito na yung mga, kung naaalala nyo, guys, yung lesson natin before sa Principles of Steel Design, yung combined axial and bending, yung meron tayong ratio na kino-compute, yung interaction ratio natin. Basically, ito yung mga answers nila. So if you would be changing this, so palitan natin yung load into a combination, let's say 1.2 dead load plus 1.6 live load. So basically ito, no? And if you can see guys, ang liliit ng value. 0.019, 0.259, and ang maximum natin para mag-fail, 1.0. Pag umabot siya sa 1.0, fail na yung ating members. But as you can see, ang layo-layo sa 1.0, ang layo-layo sa 1.0 na itong mga values na to. And with that, guys, it is better that you would be selecting a new member. So paliitin natin, ang laki kasi masyado ng 6x6. So siguro pwede yung 4x4 or let's say 2x2 na angle na built-up section. So yung mga ganon. Or better yet, if you would be going to the analytical model once again, then you would be going to the design. So balik tayo dito sa parameter na to. So AISC 360-10. Go to commands. Then meron dito select optimized. So what this does is that once it would be analyzing, mamimili ngayon si STAAD ng mga optimal na section. So if I would be doing that, so select optimized. Teka, feeling ko mag-error to eh. Pero sige, try natin kung mag-error. Apparently not. Okay, so ito. Kailan natin nag-optimize siya. Pero may warning. Hindi ko alam kung ano yung warning na yan. So, view output file. So, according to the warning, ito, sabi ng warning, some member sizes have changed since last analysis. Dito kasi kapag linagay nyo yung option na yun? Select optimized, babaguhin niya yung mga AISC section. Parang ito, no, pinalitan niya ng L20203. Ito, L25203. Ito naman, L50354. So, lahat sila naka-AISC nomenclature. So, yun yung, ang pangit dito guys, iba-ibang section yung ginawa niya. So, for you to simplify it, just go back to your properties, then palitan mo ngayon yung mga section according sa mga suggestions niya. So, ito yung mga suggestions niya, no? Palitan mo na lang ngayon guys. Tapos, i-check nyo ulit yung adequacy, then go to post-processing, then go to utilization ratio. I-check nyo pag tumaas yung mga yon. And as you can see in this part right here guys, yung interaction na natin dito. Teka, nawala. Interaction diagram na natin dito guys, 0.905, 0.98, 0.88, 0.924. So if it is near 1.0, it means that it is designed optimal. So hindi siya over-designed, sakto lang. And as you can see in this one right here, 0.29. Bakit kaya hindi niya rin i-design kung 0.29 to? Kasi masyadong mahaba to guys. And siguro kapag liniitan natin yung section, mag-fail siya sa KL over R or R slenderness ratio. Basta ganun lang yun dito sa steel design. So that is basically it for our lesson for today. But before dismissing you guys and before ending the meeting, are there any questions about anything under the sun? So, understood guys? DC, kuha. Okay, very good. Mr. Basco, okay?
Yes po, sir.
Very good. Miss Manuel, okay?
Yes, sir.
Okay, very good. Mr. Chong.
Opo, sir.
Mr. Mercado.
Yes po.
Okay, very good. Okay, so if there are no more questions, bago ko pala i-end, meron pa pala kasi tayo dito guys na supposedly ile-lesson ko pa pero medyo nag-overtime na tayo. So if you would be going back here, so in this one, if I am to scroll down, meron din tayong mga deflection limits. And I am pretty sure that you already know all of this. So eto no, so sinabi niya dito for our members, it should not deflect by L over 180 or L over 120 for, not supporting ceiling pala yan. Pero meron kasi tayong ceiling. So meron tayong ceiling, no? So meaning that this is to be our deflection limit. So siguro ito, mas maganda ata to. So L over 360 if you would be using live load, L over 360 if you would be using a wind load, and L over 240 if you would be using dead load plus live load. So check natin to guys. So as you can see here, so our length, and by length guys, ang ibig natin sabihin is to be this one. Teka, paano na magpakita ng node to node distance? So ito from this point up until this point. So 12 meters yung L na gagamitin natin, hindi yung original na 20 meters. Ito support to, no? So if this is to be 12 meters, tapos, so 12 meters, oops, ba't ang laki naman nito? Teka. So if this is to be 12 meters, divided by, teka, nakalimutan ko. Divided by 240. Ito yung gamitin natin ngayon guys. So 12 meters divided by, teka, nakalimutan ko agad, ka-check ko lang. So 240. So 240. So the maximum deflection of our nodes should be, so yung calculator ulit natin. Calculator. Okay, so 12 over 240. So multiply natin ng 1,000 para ma-convert sa millimeters. So our maximum deflection is to be 50 meters. Well, max deflection. So if that is to be the case, tago lang ulit natin yung ating calculator. So let's go to post-processing for us to check kung pasado yung ating truss sa, sa deflection. So go to post-processing, go to displacements, then siguro dito, right-click tayo kahit saan dito guys. So right-click dyan, then result setup, then ang piliin lang natin is yung dead load plus live load. So lahat yan, lipat natin sa kabila. Then ang piliin lang natin is yung 1 dead plus 1 live. Kasi yun yung deflection limit na to. So click this, click apply, then okay. So as for its vertical component, no? So ito yung gagamitin. Ito yung check natin. So masyadong malayo yung mga deflection, no? Kasi hindi natin pinatan yung section dito. So masyadong malayo yung mga deflection sa 50 mm. So sorry, 50 mm pala dapat to. So ayan, so in other words, pasado yung ating ating truss, basically over design pa nga. So that is pretty much it for this, for our lesson for today. So once again, are there any questions? Okay guys, so if there are no more questions, I would now stop the recording.